This is the Amp Hour podcast, released May 15th, 2023, episode number 632, with Steve Sanghi discussing being CEO of Microchip Corporation for 31 years. Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Steve Sanghi. For 31 years, I was the CEO of Microchip, now the executive chair of the board.
Steve, great to talk to you again. How long's it been? 13 years since we last had a chat?
Yes, Dave, that was a long time ago. I think our Picket 3 had just come out, and
That's right.
there were some things you didn't like about it, and I took that feedback, very
Yes.
correct.
And then you guys made a hilarious response video, and yeah, that was great. That was good
Yes.
times. So 31 years as CEO of Microchip, and you've only recently stood down, and now you're executive chairman. Is that right?
Yes, so I stood down in March of 2021, 2 years ago.
Right. And why was that? You just you've had long enough there. You wanted to retire, hand the
Oh,
reins
no,
over.
I was, almost 66 years old, and I needed to pass it on to my successor, Ganesh Murthy. And, so I'm still working for Microchip 3 days a week,
Right.
but I have ample time. So I wanted to really, my family made a lot of sacrifice over those 40 years or so
Yeah.
in business. And I wanted to really spend more time with them and reduce my hours at Microchip a little bit. I was working 7 days a week and traveling 100 nights every year, and it was just,
Oh, yeah. That's tough.
yeah.
No, I can understand. So you've now written a book. We might talk about it a bit more at the end, but is that what's that about?
The title of the book is Up and to the Right. That's the main title. And then the subtitle is My Personal and Business Journey Building the Microchip Technology Juggernaut. So the
Excellent.
book is really my, 31-year history of building Microchip, and also has a little bit of personal stuff. My growing up as a small boy in India, how I came to United States, and early years I went through a lot of hardship like most immigrants, and how I got into business, and then Microchip, and just a tremendous success building a $43 billion market value, just
Wow.
absolutely a juggernaut. So that's really what the book is about.
That is amazing. Hey, can you tell us very briefly? I don't want to go through the book, but tell us very briefly, how do you become the CEO of a large company like? Well, it was it Arizona Microchip back in the day? I do have a recollection that it was called Arizona Microchip. Is that right?
The name of the company was never Arizona Microchip. It was Microchip Technology Inc.
Right.
It's a European name, and some of the Asian countries they branded Arizona Microchip.
Ah,
But Microchip was too generic, and
right.
those countries apparently added Arizona to it. But here in the U.S., or the main company's name was always Microchip Technology Inc.
Got it. So
So
how do you become CEO of a company like that? What's the path? What's the
Well, there are two ways to become CEO of a large company. One is to become the CEO of a small company and then make it large,
Right.
which is what I did. I joined the company when I was a $60 million company losing money. We turned
Yep.
it around, took it public, and just built it a absolutely juggernaut. We just completed a fiscal year with sales up $8.4 billion.
Nice. So
These
you didn't start out as CEO though. You were working there as something else at the time, were you?
I came to Microchip as a senior vice president of operations, and after 1 month of me being here, the board took out the CEO because the company wasn't doing well. And
Right.
then there was a 3 months of search out. They talked to internal and external candidates, and then I got the job about 4 months after I came to Microchip.
Oh, fantastic. Because Microchip almost went bankrupt in 1990, didn't they? Is that before or after you took the reins?
So Microchip really never went bankrupt. I almost did. So after I took the job, we basically were losing money and didn't have enough money. Venture capital was very hard to come by. I
Mhm.
wrote a business plan and started raising money. Took me about 9 months to raise money. During those 9 months, every other Tuesday, I wouldn't know whether the paychecks will clear on a Friday.
Ooh, ouch. That is rough.
So if any of those Fridays the paychecks had not cleared, then we essentially will file bankruptcy. But we never did. We turned the
Oof.
company profitable. I raised new money.
Mhm.
2 years later, took it public and up ever since.
Fantastic. So did you change, product strategy or something? Did you Is that how you helped turn it around, or was it the capital raising that allowed you to buy time to
Well,
drive in different directions?
massive overhaul. And, actually, the second chapter of the book talks about the transformation of Microchip from what we were to what we have become. Microchip originally was an EEPROM company. We used to make EEPROM memory
Yeah.
products. And, the prices in EEPROM memory products are very low. It's a commodity market, and very, very competitive prices from Japanese and Koreans and others. So the company was really losing money selling EEPROMs. And the strategy we changed was to turn the company into a microcontroller company. We took the PIC architecture, which was, had some two or three ROM-based products, about $1 million a quarter business. So it was very small business.
Mm.
And we applied our EEPROM technology to the microcontroller architecture to make the field programmable microcontrollers, which could be programmed by the customer rather than programming in the factory by sending your code to Motorola and waiting for 16 weeks, for the parts to
Yeah.
arrive. And during that time, your code changes and you start over again.
That was game changing, wasn't it? I mean, that was the PIC 16 C54, that was the first one?
Exactly. It was a game changer. It was absolutely a game changer. And I write eloquently in the book about, how the field programmability changed the game. There's a story about it, which is also in the book. I was visiting a customer in Europe, in Germany, that was building remote controls. So they were making remote controls for every single TV, audio, video, karaoke, garage door openers. They were making about 500 different remote control models in a given year,
Wow.
and they used to make them for Sony and Seiko and all the
Yep.
video, audio, TV players. So, but they were only making remote controls for other people. So, and they were using Motorola product, obviously ROM-based product.
Mhm.
So I went to visit the customer, and the president showed up in the meeting. So I asked the president my favorite question, which is, dear sir, what is it that you cannot do today, but would love to do if you only knew that it could be done?
Mm.
It's a powerful and profound question if you think
Yeah,
about it.
totally.
Did it a couple of times, and I said, "What is it that you cannot do today, but would love to do if you only knew that it could be done?"
Mm.
He said, "Follow me to the production floor." We went to the production floor, put our smocks back, and he said, "Look at all those pile of parts. There are obsoleted codes where the customer
Oh.
had changed the codes and the parts are scrap. Look at those 14 people behind the glass. They're all on the phone with Motorola trying to expedite the parts on which the demand was stronger. And, it's like we're going crazy. We have to forecast 16 weeks ahead of time an exact model mix of those 500 different codes. Can you help me?" I said, "Yes, sir. Music to my ears." I said, "Change all those parts to a microchip microcontroller, then all you have to do is buy the number of remote controls you build in a month. No model mix issue. Your night shift programs it, and your day shift puts them into the socket." And guess who got the business?
Yeah, exactly. Oh, wow, yeah, 'cause, so you guys were the only ones who had a reprogrammable microcontroller, field programmable
So I think
reprogram.
to be honest, Motorola, Intel, and I believe even Hitachi had a EEPROM based field programmable part, but they were about 10x the price.
Ooh,
So they were not used for production version.
right.
They were really used for prototyping, where you can program and reprogram, use it for production, you use it for
Mm.
prototyping.
Or for very high value added, products, very expensive products.
That's right. So what
Yeah.
we brought to the market was a field programmable product, which was only, I think, about 20-25% higher price than ROM, but tremendous value and time to market.
Wow. And then so when did you make the switch from E squared prom to Flash?
So so first we went from EEPROM to E square. I think there was a PIC 16 C84, which was a E
That's
square
right,
based
yeah.
product, and you can really byte program it, change a single byte. And then around the 1995 timeframe, we introduced the flash based products where you can flash erase the whole part and flash program the whole part.
Right. And, what was like, how do you change your fab, like, process node or whatever it is to change from, EEPROM to then E squared prom and then to Flash? Is it like a major upgrade to your fab, or how does that work?
Those were all distinct technologies. So today, we still make the original PIC 16 C54,
Yeah.
and that EEPROM technology still runs in our fab. We still make the 16C84, which is an E square technology, and we still make it. And we make a whole bunch of flash parts that you can buy from 16F505 to even 16-bit parts and high-end 8-bit parts.
Mm.
There are 2,000, 3,000 different variety of PIC microcontrollers today. So all those parts run into the fab. So each one was a different technology that we developed and then implemented and put the designs on those technologies.
Right, so how easy is it to change your fab, like, to, like, suddenly spin up a Flash part as opposed to a E squared prom part? Is it, like, really easy to do that?
You mean the designs are already there,
The
process
the the
already.
designs are already there. How do you change the process on the manufacturing floor, so to speak?
So all those processes are in production volume, and I can today start 100,000 parts of 16C54. Tomorrow I can start a mask set which runs on the E square process, and the day after I can start the mask set which runs on the flash process, or on a given day you can make all three. There is
Oh,
enough
wow.
equipment in the fab to really make all those parts in parallel.
Oh, wow, okay, fantastic. So how many fabs do you guys have, and where are they?
So Microchip owns three large fabs. The oldest one that we have it in Arizona. It's in Tempe, and then the second one is in Oregon. It's right outside of Portland in a city called Gresham. So the Tempe fab and Oregon fab are 8-inch fabs. And then we have a third fab, which is a 6-inch fab, which is in Colorado. And we got it when we purchased Atmel. It was Atmel's fab.
Oh, right, yep,
And then we probably use 20 other fabs around the world in Taiwan and Japan and China, basically products that we buy from subcontractors like TSMC, Global Foundry, UMC, and others.
got it. So what percentage of your products would be made in your own fabs, do you think,
So
roughly?
about 42% of the products are roughly made in our fab.
Oh, wow.
Rest are made in foundries. So, that number was almost 98% made inside prior to us starting, the acquisitions
Yeah.
and starting to build the products in TSMC. So I would say, almost till about 2008, 2009, we made most of the products ourselves.
Right.
then two things happened. Number one, we started to do acquisitions. So when we, for example, bought SMSC in 2012, they were 100% fabless. When we
Ah,
bought SST in 2010, they were 100% fabless. When we bought Micro Semi in 2018, they were largely fabless. So when we bought all those companies, then fair amount of our business started to be from the foundries.
got
And
it.
the second reason is as the technology migrated up, especially to 300 wafers
Mhm.
and past the 90 nanometer, 65, 40 nanometer, 28 nanometer, all those are very advanced lithographies, and microchip doesn't have 300 millimeter capability inside. So all
Right.
those we're buying from foundries. So as that business grew, that also increased the portion of the business we get from outside.
Got it. But you are looking at building your own a new 300 millimeter fab in Gresham, aren't you? Is that still happening or?
So we did a large study whether we could do a 300 millimeter fab owned by us
Mhm.
with a CHIPS Act grant from the U.S. government that was approved a few months ago that you could apply for the CHIPS grant money. But we were doing that because our foundries had told us that they're not going to add any trailing 300 millimeter capacity. So they were foundries told us that they would not add any 300 millimeter capacity at the 90 nanometer, 65 nanometer, and 40 nanometer nodes. So we had decided to do ourselves. But
Right.
as we were still, working on and getting the money and laying the plans, the foundries changed their decision and they said they will add trailing 300 millimeter fabs because
Mhm.
apparently their original analysis was that the trailing edge demand wouldn't be there. But a lot of the equipment are industrial equipment, automobiles, all sorts of products built. They're all built on trailing edge technologies. All the
Mhm.
analog is built on trailing edge technologies. It's only the advanced processors by Intel and Nvidia and AMD and Qualcomm, they are built on what we call bleeding edge technology.
Yeah.
All of microchips, microcontrollers are built on trailing edge technologies. So as the foundries started to get that feedback from us and ADI and TI and
Mhm.
NXP and ST Micro and Renaissance and others, they changed their mind and they said they would add more trailing edge capacity. So
Uh,
we scrapped our plans. We'd rather have
oh,
them
it's scrapped.
develop.
Okay.
Yeah.
So even if the government gives you money through the CHIPS Act, you won't build a new fab? You don't think you will?
Currently, we are planning to expand our 8-inch and 6-inch fabs because the demand on them is tremendous, and we'll get some CHIPS Act help for that. But
Oh,
not
great.
building 300 millimeter fab from CHIPS Act. Well, the government did a little bit bait and switch also.
Right.
So basically, they came up with rules that if you take more than $150 million help from the government for a given project, and a 300 millimeter fab will be a $5 billion project. So we'll get a lot of help from the government. Then you have to put a unionized workforce. You have to build a daycare center. You have to share your profits with the government. You cannot buy back
Oh.
your own stock. You cannot increase your dividend.
Oh, wow.
Yeah, so it's like hey, that's so you're asking us to swim in a highly competitive world with just the
Yeah.
one party.
I think the name for that is, golden handcuffs.
Exactly. So a number of companies have decided to not take the government money, and we're going to take the government money but stay below the $150 million per
Right.
project, so we don't have to do all those things and use that money to expand our existing fabs.
Got it. That makes sense. Okay. So, you wouldn't be able would you actually be able to get capital somewhere to build your own fab that wasn't government money? Would that even be possible?
Well, I mean, no, we are, number one, we're very profitable. We can fund a fab ourselves if we absolutely needed the fab, and
Mhm.
if the foundries had told us that won't build a trailing edge technology and they had not changed their decision, then we will build a 300 millimeter fab,
Mhm.
and we probably will only take $150 million from the government and rest we can cash flow ourselves. We're
Mhm.
very profitable. We can borrow money. We can sell our stock to raise money. We can sell bonds. We
Yep.
can do a lot of things. So the problem wasn't really being able to fund the fab. The problem is, building the fab in US with all the regulations and all that is more
Right.
expensive, than building a fab in some other countries. So we wanted a government subsidy so the fab can be cost effective. But if they give you a subsidy on one hand and raise the cost even higher on the other end, then it's a mute point.
Got it. Are you making any chips in China at the moment through any fabs in China?
We are making very few chips over the last several years as the rhetoric between US and
Yeah.
China kind of ratcheted up. We have largely withdrawn from manufacturing in China. We own no assembly or test plant in China.
Mhm.
Some of the packaging we do, we have moved it outside. We probably do less than 5% of our packaging in China.
Right.
And for wafer fabs, we probably, do only maybe 2 or 3% of our manufacturing in China on wafer fabs.
Interesting. So, what about raw materials and things like that? Are you reliant upon China for those? Like, if, say, if trade with China stopped tomorrow, would your fabs not be able to get material or?
So we are reliant on China on those, but even on those things, we have built second sources for most of the materials.
Right.
So if the supply line were to get totally cut off from China, which nobody's expecting it,
No, but
then the other sources which we have qualified, will have a lot of constraints on them, and we won't be able to get everything we want. So we're still relying on China for a lot of those rare earth materials and other things. But the
okay.
sources are being developed outside of China to become self-independent there too.
What sort of rare earth materials are used in chip fabs?
I wouldn't be able to name them, but palladium is one of them, for example, and there are
Mm.
others.
Okay,
Yeah.
interesting. Can we talk about the supply chain and COVID? Here's a big topic. Can you tell us what happened during COVID? Because my let's see if my story ties up with, well, from what I've heard, ties up with what you know. The supply chain crisis happened because when COVID came around, all the major automotive manufacturers and all the big manufacturing, all your big makers like Apple and everything, they panicked and stopped ordering parts, which then meant you guys, that changed all your pipeline and everything. And then 6 months into it, they realized that, oh no, we better start making chips again. And then you guys couldn't ramp up fast enough. Is that what happened? Or,
Somewhat that happened, but it's more complex than that. So,
right, tell us.
so COVID started in about March of 2020, and in June of 2020, the automotive demand had gone to about 20% of normal. So automotive manufacturers cut back that much, not for the whole quarter, but it was sliding down. And in the month of June, it was about 20% of normal.
Wow.
And we begged automotive manufacturers that can't be a reality. You're just responding to this short-term thing. Give us a longer-term forecast. What happens in 6 months? What happens in a year? So we maintain capacity and not leave you high and dry. And nobody was giving any forecast. Nobody was talking. Nobody knew what's going to happen. So while the automotive demand was down, the demand in two areas skyrocketed.
Right.
One was in work from home.
Yes.
So I would say large number of our employees have a desktop in their office.
Mhm.
And when they started working from home, we had to buy them a laptop.
Right. Instant demand for laptops and monitors, external monitors and things.
Yeah, so we had to buy them a laptop, a monitor, a docking station,
Right.
upgrade their broadband in the house, a printer for be able to print things. So the demand for things needed for work from home, even headphones and others, it skyrocketed. And the second thing that happened was medical. So I'll give you an example on medical. In March of 2020, if somebody had asked me, what is a ventilator?
Yeah.
A ventilator, it must be some sort of fan, maybe an attic fan in Phoenix to get the heat out. But then I learned that ventilator, was this pump that pumped oxygen into the lungs of the patients that couldn't breathe. And every design around the world, I would say 90% plus of the designs around the world had a pick in it.
Oh, really?
And that demand went up 1,000x.
Oh, 1,000 times. Wow.
Yeah, 1,000 times. And it was not only ventilators, also, digital thermometers,
Yeah.
temporal scanners, glucose pumps, and diagnostic equipment. And when the COVID test kits started to come out, they all had our products in it too. So the demand for medical just skyrocketed and took us more than a year and a half to supply that demand. So the automotive capacity got shifted to medical and work from home. And then 4 or 5 months later, when the automotive came back and saying, "Hey, we want our parts," we had no other capacity.
Wow.
And then everybody got constrained and still are. I mean, our lead times are still, you know, 26 to 40 weeks on most of the products.
Yeah. That was common back in, like, the late '90s, wasn't it? I can remember, like, 40-week lead times being very common, and then it seemed to be plentiful in the last 15 years or something, and now it's, like, 40 weeks again.
Yeah, so we are on record to say that we'll bring the lead times on all of our products, down below 26 weeks by end of September. So it's not
Right.
too far away, and I think, and then continue to bring down beyond that. Other companies are doing the same thing. So things are normalizing from COVID. The medical demand has been met, the PC demand has been met. Actually, PCs are soft. Automotive demand is rising, but now the switch is happening. The capacity we had given it to PCs and work from home and medical, now we can give that capacity back to automotive. So we're catching up.
Us engineers, we think we foolishly think that the chips are the bottom of the supply chain. Like, oh, I can't get my chips, therefore I can't build my products. But to you, it must be different. It's like, well, if there's a supply chain crisis, I can't get my wafers, I can't get my chemicals, I can't get, all the things I need to build those chips. It's like turtles all the way down. Did you guys have any supply chain problems for stuff to make the chips?
Yeah, we had huge problems to make the chips. So, we were expanding our fab and were adding equipment in our fab. And when we will order the equipment, the companies like Applied Material and KLA and others we were buying the equipment from will give us a delivery date when the equipment will be shipped. And let's say they told us it will arrive in September 2020. And it didn't arrive in September 2020, it arrived 6 months later. What happened? Because many of them couldn't get semiconductors to build the equipment. So in many cases, we found out if it was our chip, then we preferentially gave the chip to those people who will help us, give the equipment. But we're not,
Right.
but we were not the only chip in those equipment. Even if you gave ours, maybe they couldn't get it from TI, they couldn't get it from somebody else. So eventually, everybody figured out to help the gear manufacturers so they can build enough gear to really so that we can improve production. But that was not the only thing. Then our stuff, let's say, was coming from Japan, and it sat outside of Los Angeles harbor on the ships for 8 weeks.
Oh,
So
right, because
because
they couldn't get the port workers or whatever, the dock workers, is that right?
and they couldn't get enough. They couldn't get the port to be working efficiently enough. There were union workers. They were working one shift, and it was overloaded. So ships sat out in the ocean for 6 to 8 weeks. So by the time they were able to offload our stuff and they put it on the ground. Our truckers had bailed out saying, we got other jobs to do. We've been waiting
Oh,
for a week to wait for your equipment and we're leaving. So then it took us 4 weeks to get the truckers back. They took the equipment to Oregon where we needed to install it. By that time, the installers had bailed out and saying, well, we got other work. We got to make money. We've been waiting for a week for the equipment to arrive. So there were delays after delays after delays after delays. So therefore, the commitments that we had made to the customer a year out based on our capacity growth plans, we had to break those commitments because that capacity growth didn't happen because we didn't get the equipment.
wow, that is like it's hilarious that you were able to supply actually prioritize your chips to make the equipment, but then they got stuck in the on the docks or sitting on the ships and you couldn't get to them. That's wow. That is crazy. Did you have any problems with like chemicals and things like that? Because fabs use lots of chemicals and whatnot.
We did have some issues with chemicals, but I think we were hand to mouth. We
Right.
never we never shut down because of chemicals because there was a fair amount of chemical supply available onshore from lots of people that make chemicals. So we did come hand to mouth few times where ordinarily we'll have 6 weeks of supply of chemical in house and we never want to shut the fab for a stupid chemical.
Yeah.
And then we came within a week of shutting down, but
Ooh.
we never shut down because of that. Now,
Right.
the one other point I wanted to make is, where historically over the last 40, 50 years, customers have dealt with the chips as jelly beans.
Yes.
Whenever you want them, they will be there. Automotive suppliers never paid enough respect to the semiconductor suppliers because, I got lots of suppliers and chips are available and, whenever I need them, I will have them. And they, for a decade plus, they were driving these JIT program just in time. I don't want any inventory.
Yeah.
All the inventory, give me what I need. And automotive manufacturers got a big lesson in the last 2 3 years. 3 years. Basically, what happened is for the shortage of a $2 chip, they couldn't ship $80,000 car,
Yes.
and they lost so much money, billions of dollars, that most auto manufacturers have now changed their strategy from JIT to JIC. JIT was just in time, JIC is just in case.
Yes.
And now they're all planning to stock an inventory of product. So if this kind of thing happens again, they will not have billions of dollars of cars that they cannot ship.
Yes, I heard that even Toyota did that, and Toyota basically invented just in time, didn't they, with the Toyota production system?
Absolutely. I mean, if you go, look at in Japan, wherever the Toyota's factories are, the big trucks and big rigs are lined up in the alleys behind Toyota's plants, and they are supposed to deliver the product to Toyota every 4 hours. Toyota keeps no inventory. So every
Oh,
4 hours,
wow.
truck pulls up and supplies it, then gets on the back of the line, gets back. So I mean,
Oh,
that's how it worked, and now all those trucks were empty. There were no parts in it, so Toyota had to shut down factories too.
oh, wow. Yeah, that's a lesson hard learned. Really, it worked for what, 30 years though, didn't it?
It worked for a long time. So I think now, semiconductor industry is getting healthy respect, getting respect from automotive guys, getting respect from the rest of the market, getting respect from the governments, and they're basically, semiconductors are the new oil of the economy, right?
Mhm.
For
Yeah.
so many years, the crude oil was, whoever has the oil has the power because energy was needed. And now nothing happens without semiconductors, so they're becoming the new oil.
Right. Can you I don't really wanna get into this, but it's what I probably have to ask. What do you think would happen if China invade Taiwan? I mean, how big a disruption would that be with Taiwan being what, 70% of the chip market globally? Is that right?
Does Taiwan make 70% of its chips? I think that number is high.
Okay.
Yeah, so but it's like, it's probably 70% of the advanced
Of the
manufacturing.
advanced ones, yeah, that's
Yeah.
probably what it is. Yep.
So, if China invades Taiwan, that's a huge problem. And everybody, number one, is hoping that it wouldn't, wisdom will prevail. Secondly, if China does invade Taiwan, shutting down world's chip supply, I'm not sure how it helps China, because
Yeah.
the world then shuts off everything.
Oh, totally.
The U.S. shut down Huawei a few years ago, and if all the chip supply and all the raw materials and everything else stop going to China, then China becomes a third world country. So I think it's kind of a mutual destruction, and everybody's hoping that
Right.
that won't happen.
Yeah, I suspect so. So let's talk about the sheer number of parts. This was a question that some people asked. You make over, I think, over 1,200 variants of just the 8-bit microcontrollers. How does it make sense to make so many minor variants of, one family or one part? How does it make sense from a production point of view, from a supply chain point of view? How does that work?
So I think, over the years, for 30 years, and let's go back to, when 8-bit microcontrollers were, 6, 7 years old. So we started them in 1990 and let's say 1998 timeframe. We would analyze our design wins and design losses, and we will find design losses because, we didn't have a PWM on the chip and somebody else did,
Right,
or we had one 8-bit A to D, and somebody wanted A to D and two PWM channels, or we had, what would happen is customer would say, I love your architecture, I love your product, it's great, but I wanted a USB on board. So we'll say,
mm.
well, here's a part with USB on board, but that only has 40 pins, I want 68 pins. Okay, here's the part with 68 and USB, but that doesn't have enough PWM channels. So that really happened because customers wanted it, and we wanted to win every design, so we kept proliferating it, and we had to invent a system in our manufacturing where you can order any one of those 1,200 variants, and we will make them and make them cost effectively, and keep our inventories in control and keep our business very profitable. Which is, by the way, is a skill in itself. Now, Costco knows how to do it, Walmart knows how to do it, but I don't think Intel knows how to do it, and I don't think AMD, Nvidia don't know how to do it,
Right.
and many of the other semiconductor companies, Qualcomm and others, may not know how to do it. Microchip does, and obviously analog guys knew how to do it. Maxim and
Yes, of
Linear,
course.
they knew how to do it. ADI knows how to do it, and we know how to do it. So we did it because we would lose design because customer didn't have the exact part, and many times we would then make a super chip that had bunch of PWMs and A to
Yeah,
D, and have USB and have Ethernet and have all that stuff, and then we would lose the design because our part wasn't cost effective because we put too much into it.
got it. Are you going to share with us what the secret is there, or is that a trade secret? Are there any tricks to being able to produce so many parts on a whim, like just bang?
So it's probably a trade secret. I think others have it too, and we don't know if the others do it exactly how we do it. But I mean, we're not the only one who does it. Who's good at it. I would say ADI is good at it. I would say TI is good at it. So there are other people who are good at it, but I do not know whether how we do it and how they do it is exactly the same. I think TI does it through inventory, and
Right.
their inventory is a lot higher than us, so they kind of do it through inventory. We don't really do it through inventory, and therefore I think, yeah, it's probably, some others would like to know what Microchip does.
The MIPS versus ARM thing, can you tell us the history behind that? Why did you go into MIPS when everyone else was doing ARM?
So that was a long time ago. We had essentially a bake-off between MIPS and ARM, and we found that ARM's proposition in terms of upfront license fee and royalties were much more draconian because of their market share than MIPS were. And a lot of our low cost competitors like Atmel, I mean, Atmel will sell a chip for half the price we would, and they won't make any money at it, but it didn't matter. When I bought Atmel in 2016, they were making zero profit.
Wow.
And today they're making over 40% operating profit under Microchip. So they didn't have the pricing discipline. They, absolutely did not. So, if we had gone to ARM, then competing with a lot of low cost competition and having no differentiation, we thought we wouldn't be able to do what Microchip wants to do, which means be differentiated, sell with profits, and grow our business responsibly. We couldn't do it with ARM, so we went to the MIPS architecture, and our MIPS was quite successful. And even after we bought Atmel, which was ARM, we looked at it 3 years after, our MIPS business had grown as much as ARM had from the point of acquisition and forward. So now we kind of eliminated some of the very low cost competition. So then after we bought Atmel, we kept doing both, but eventually we decided that if it's a general purpose part, then we will build them on ARM. If it's a part where the core is not visible to the customer, means we're building a CSIC for a single customer or single application, and we put the program in it and the customer doesn't see the architecture, then those ones we will still build with MIPS because financially it's a better solution.
Got it. So how did the Atmel, buyout happen? Did they approach you? Did you guys, like, poach them, or and how did it go? How was the, transition of buying them?
So, Atmel's board had decided to sell the company. So they got investment bankers, which were I think Catalyst is the name of the company. That's the bankers who were trying to sell Atmel. So we were approached by the bankers saying Atmel's board has hired them to seek for bidders for Atmel. And and then lots of companies looked at Atmel, including us. There's an entire story about Atmel acquisition in the book. But originally, what happened is, Atmel gave us a non-disclosure agreement to sign, which I wouldn't sign
Oh.
because it had some draconian terms in it, and I don't know whether they gave the same draconian terms to other companies, but they did give it to us. You may recall that we tried to buy Atmel hostile back in 2008.
Oh, that's right.
So that
Yep.
acquisition failed because it ran into the global financial crisis. But some of the bad blood at the management level stayed between Atmel and Microchip. So this was now 2015, about 7 years later, when the board was trying to decide, sell it. The management CEO and the bankers gave us a non-disclosure agreement that I wouldn't sign. So then everybody else was looking at it, and we were not because we were outside. We wouldn't get any information. So eventually, I reached out to the chairman and I asked him to give me a meeting. And that meeting happened in San Jose, where I impressed on the chairman that Microchip is probably the most likely viable and qualified buyer for these products. Looking at our record of acquisitions and how successfully we made them, if he didn't include Microchip in the process, I think there'd be a lot of questions asked by investors and lawyers and others. And so he agreed to, essentially, help us take a look at the company, and he would soften the NDA a little bit, which he did. So subsequently, we signed the NDA, and then we made our offer to buy Atmel. So our original offer to buy was at $9 a share. Then chairman called me and said that we were not the highest offer. There is a higher offer than us. But if I were to raise my offer to $10, then he'll be willing to swing the board to really go with us. I said,
Right.
our offer was not pulled out of the air. It was done based on a lot of analysis and all that. And what we came up with was a $9 value, and I wouldn't raise it to $10. So
Right.
then we didn't hear anything from them. And a few weeks later, the news came that they signed the agreement to be bought by Dialog
That's right.
Semiconductor. But the offer from Dialog was in the form of large amount of Dialog stock and some cash. So mostly
Mm.
stock, but some cash. When that offer was announced, Dialog stock went down precipitously. So when the Dialog
Oh, wow.
stock goes down, the value of Atmel's offer goes down.
Yeah.
And every day, every week, Dialog stock would go down and the value of Atmel offer will go down. The original offer started with $10.40. When the deal was announced, the value of the offer was $10.40. And it kept going down, 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 and it went below $9. When it below $9, and I wrote to the
Wow.
chairman again and I said, Mine now is a better offer." And then that resulted into us engaging again. But now Atmel's business was also starting to fall. So we said we need some new numbers, new information where the business is, and we got those. Based on that, we eventually were able to buy Atmel at $8.15.
Wow. And how's the transition been in terms of, merging their products in? Have you discontinued any Atmel parts at all? I don't know.
Yeah, so we did not discontinue any Atmel parts. We usually don't. Our strategy is that we build all the parts essentially forever. We merged Atmel businesses. Their microcontroller business merged in our microcontroller business. Their 8-bit merged into our 8-bit. Their 32-bit merged together. Their E Square business, serial E Square business merged with our serial E Square business. So we did a fair amount of combination. Their RF and wireless business merged into our wireless business, and together we started to make rapid improvement in products and yields and pricing and cost. And Atmel had a very bloated overhead structure. They were spending huge amounts of money in finance and legal and HR and other disciplines that don't really add value to the product as much. So we did a significant restructuring. Atmel in their headquarters, where all the overhead was in San Jose, had 400 people, and we kept only 80.
Oh, wow. That's amazing. So, these days, do you sell more microchip microcontrollers or Atmel microcontrollers?
So they're all microchips, microcontrollers. We don't care what the
Yeah,
customer
but
wants to buy. We
yeah.
promote them equally, and we are still building AVR products, and we're still building PIC products. We're still building, ARM-based microcontrollers. Some of
Mhm.
the new parts we build on ARM, they have a PIC nomenclature on it. Some of the old parts that came from Atmel had a SAM or
Yeah,
nomenclature on it.
got it. But which one sells more? Because people wanna know, are there more AVRs sold or PICs?
When we bought Atmel, PICs were selling 2x the AVR sales, and that distance is probably even larger now.
Oh, okay. Right.
Well, because for years Atmel had not done any more AVR products. They had switched their entire energy to build a 32-bit ARM.
Mm.
So therefore, AVRs were atrophying. So after Microchip came in, we said, we want to regurgitate, AVR. So a year later, we introduced 4 new hard-hitting products with a lot of Microchip features on AVR. And we also made the AVR products work on Microchip's development tool set. So we re-energized AVR and they started growing again. But PICs are much, much larger business in AVR.
I know that you have the RISC, 5 in the PolarFire FPGAs. Do you have any plans on having RISC 5, like, just, chips on their own?
We currently don't on a standalone microcontroller. We don't
Mhm.
because I think our customer base, which is largely automotive, industrial, those kind of customer base, they're really very risk averse,
Right.
and
Pun
they wouldn't.
intended. Yeah.
And we talk to them all the time. They wouldn't take the risk based part today because they don't believe there is enough ecosystem. So we are really using risk five where the architecture is not necessarily visible to the customer, or an FPGA, maybe, in future, some of our data center products and others, slowly walk the line. And eventually we may do that someday, but not in the next 2, 3 years.
So, have you guys ever discontinued a part? You said that is not your thing, and I don't recall a PIC Micro ever being discontinued.
So the name we have that for that is customer driven obsolescence. So as long as customer wants to buy the part, we will continue to make them. Now
Right.
that one was customer based obsolescence was perfect when we made all those parts internally because we could keep all those processes running. With so much of our business now really gone to foundries, we are not perfect in customer driven obsolescence. So foundry would once in a while give us a notice that they're going to obsolete a process. Then we
Mhm,
work with the foundries to go build 5, 10 years of inventory and still continue to supply the parts for a long time and
mhm.
create the in the minds of the customer, it's a customer driven obsolescence, but we're not as perfect anymore.
I've got some questions from the audience, so we'll rapid fire these ones. Do you have any plans for open source FPGA tool chains?
I do not believe so.
Okay, right, because they're getting very popular now, and a lot of people won't touch them if they don't have open source platform support.
I will ask that question, but to my knowledge, I think the answer probably right now is no.
Okay, that leads into the next question. Any plans to support the platform IO IDE or any other third party? Because Microchip's kind of famous for having their own ecosystem.
Yeah, so we support IAR, we support Kyle, we support some others, but largely yes, we prefer our own because I think we have gotten inconsistent support from time to time. See, what we could do with our products is we can have a development tool group line up their priorities with a microcontroller group. When the part comes out, the tool chain is there. If
Right.
you rely on the outside guy and you go to them and say, I have this product coming in and I need the tool chain ready by June of 2024, he says, I don't have resources, I have other priorities, I'll work on it a year from now.
Got it.
So that's the problem.
Well, in terms of platform IO, that's just an integrated development environment. It's not actually a like a compiler tool chain. So, any plans to support third party development environments like that? That are just like editor environments that are becoming very popular?
I would probably have to find out and then let you know.
Okay,
And then
no
you can
worries.
really, give that answer in a future session.
Now, this is one comes up a lot. Why do Microchip charge for compilers, or at least optimized compilers, when most other manufacturers are now offering free compilers?
So there's a story behind it.
Okay.
You recall probably over the last 35 years, Motorola or Freescale or whoever has spinned out their tools group 2 or 3 times. They spin it out and they rebuild it.
Mhm.
I don't know if you know that or not. So what happens is if you run the tools business as a cost center only and don't sell them and don't make money at it, then when the down cycle comes, like the 2008
Yeah.
financial crisis, 9/11, when these black swan events happen, some general manager says, hey, I can't handle all this cost. Plenty of third party guys build our tools and they shut it down or they spin it out. They
Mhm.
spin it out and it's fine. It looks like a great decision because you lower your cost. and then 2 years later, you're introducing a product, and the other party doesn't get the tool chain ready because they tell you, my priorities are different. Same answer I had given you prior to that, why we, why we do our own. So we have seen other companies suffer from not having their own tool chain, and sometimes their priorities and the priorities of the tool chain supplier don't line up. So
Got
then
it.
Motorola at one time bought it back, and they bought it back, and then a few years later they sold it again, with a different
Right.
management, different general manager, a different business cycle. So I've learned this over time, and in the last 33 years I've been at Microchip, I said we will never shut down or sell our tools group. We'll
Got it.
keep the priority of our tools for our microcontroller business. Anybody else who provides support to our tool chain is in addition, but not instead of us. And we're going to charge for it so we can afford to continue to build it. If we don't charge for it,
Mhm.
then it becomes a cost center, and then next general manager or next CEO shuts it down.
Got it. Yeah, I think the problem here is that a lot of our audience are either hobbyists or they're like small business or something like that. And to them, like free tool chains is a big business, but that's probably a very small percentage of your market, is it?
Yeah, well, but if they're hobbyists, then they don't really need an optimized compiler. You're really your small volume customer, then you can really use the version that is available for free, and you don't really have to have an optimized compiler. And I think some of our compilers now, you can rent them by month, right?
Oh, okay, fair enough. One last technical question on the chips and fabs. You guys do radiation hardened chips. What sort of process is it for making those for like aerospace industry?
Yeah, so we are the largest aerospace and defense supplier, semiconductor supplier in the world. We're
Really?
probably 2x larger than the nearest person. So we have very large number of chips for aerospace and defense, and many of them are rad hard. And red hat also is, various different levels. They can be radiation tolerant, and they're radiation hardened. And there's a
Mhm.
category where they are good only in the lower orbit. And there's another one which has to be good in the upper orbit. There are various ways to make them hardened. One way is where you design them with a larger tolerance. When the radiation hits,
Yeah,
it creates a lot of free electrons that move around and really short the part. So if you build the part with larger variance, then the part is more tolerant. And the second way, which almost always the case, is that you shield the device with these shields which are in processing on the wafer as well as packaging, which essentially doesn't let the radiation go through those shields onto the die.
got it. Interesting. So they're like very expensive parts to produce.
They are expensive parts to produce, yeah. So if a non-hardened part ships sells for $2, a radiation hardened part will sell for 200.
Wow,
Yeah.
that's
Well,
amazing.
but it's going in the shuttle, it's going in a
Yeah,
satellite
yeah, exactly.
that's going to be up there for a long time. I mean, look at this, SpaceX, they send a $5 billion satellite and it blows up, right?
Right.
So, there's a lot of money that's going into it, and, we get our pound of flesh. But I would
Terrific.
say this, that there is nobody who leaves Earth's orbit without microchip on board.
Wow.
No shuttle, no satellite, no vehicle, no,
Space
any
probe, no Mars lander.
no Mars lander. There is no one who leaves Earth's atmosphere without microchip on board.
Wow, that's incredible.
Yeah.
So, where do you guys sit in the like a list of largest chip makers, both worldwide and in the US?
So I think in US probably we're within top 10.
Mhm.
Could be somewhere in the 8 9. I haven't really exactly seen the ranking lately. And if you add global, then you add some more like Samsung and others, and we could be in the low teens area. So that's where we sit. That would be based on just the revenue. But another
Yeah.
thing that's important is the market value because of profitability. If you look at it that way, we're well within, top 10.
Yeah, you guys had 100 quarters of profitability?
120,
Continuous?
124 now, I think.
124.
Yeah.
Oh, wow. Is there any risk of Microchip being acquired by anyone? Like, because, in theory, somebody could just come and, hostile takeover and buy all your shares.
So I think, for example, this question was asked to CEO of TI at one of the investor conferences, about 3 years ago,
Mm.
where investors said, hey, everybody's buying companies. Look at ADI, look at
Yeah.
Microchip, look at Renaissance, TI. Why don't you go buy Microchip? And the CEO's answer was, I buy Microchip and then I improve what? So we are a very well-oiled machine, extremely profitable, high gross margin, high operating margin, and a lot of different industries running very well. So that's one issue, that we're running very well. So people don't see how they're going to improve. And to buy a company, you have to pay a significant premium, and you have to improve them to earn the premium. And like we
Right, to
improved
actually
Atmel.
make a profit out of it. Yeah.
Yeah, so like we did with Atmel, so they don't find what they can improve. And second thing I think is right now trying to get antitrust approval, especially from China, would be largely impossible because of the strained trade relations between U.S. and China. China is not approving any of those large deals.
Alright, so Microchip's not gonna get bought out anytime soon. Good to hear.
No. So I think
Excellent.
if I could spend a minute on the book.
Oh, yes. Well, I was gonna finish up on that right now because our hour's up. So, yes, please tell us about the book.
Yeah. So the title of the book is Up and to the Right. And the subtitle is My Personal and Business Journey Building the Microchip Technology Juggernaut. And I think I, recommend the book to your audience. It's available on Amazon. The book starts with, my upbringing, growing up in India, and then how I came to America. I went through very difficult times. I came to US with $150 in my pocket with nothing to fall back on, no place to stay, just admission to a master's college, and went through a lot of early struggles, but then graduated with
Wow.
a 4.0 GPA from University of Massachusetts and went to work for Intel, worked there for 10 years, then at another small startup, and then finally came to Microchip in 1990. And then on, after first chapter, it's largely building the Microchip technology juggernaut, how we transformed the company, how we took it public, went through the significant growth phase, in 1993, when we public, we were $85 million revenue, and by 2000, 6, 7 years later, we were about 750, $800 million company. Had
Wow.
had grown really just tremendous. And then we started buying companies, and there are 3 chapters on negotiating the deals, buying the companies, financing
Interesting.
them, how we improve them, how we ported our culture to Microchip. There's a chapter on crisis management.
Ah,
Every company sooner or later will have a crisis. And, I talked about crisis of Y2K, then 9/11, then 2008, 2009 global financial crisis, then COVID, what we did, how we came out of crisis stronger than we went in, and, how we gained market share. I talk about a strategic planning process. I talk about how we sustained continuous improvement for 31 years. I talk about Microchip as a top training organization, how we acquired low cost manufacturing capacity, how we delight our customers. I talk about succession planning and promoting internally, our compensation system. And the final chapter before summary is a chapter which is titled 31 Years at a Glance. So when I
mm,
was writing that chapter, I had pages and pages of charts, revenue, growing, gross margin growing, operating margin growing, market share growing, stock price growing, dividend growing, and all these charts.
Yep.
And all these charts had one thing in common: they were all up and to the right. And that's where the title of the book came from. Till I wrote that chapter, I didn't have a title for the book.
Right.
So I think anybody, your audience who use Microchip's products and have used them for many years, if they have used them for 5 years or 30 years, it doesn't matter, will relate to things in the book regarding how we did to build this juggernaut and how we financed it, how we took it public, how we transformed it, how we grew it. So I think people will enjoy it. And if they buy the book and they enjoy the book, then also please ask them to give me a review on
A
Amazon.
review, yes, most
Yeah.
important. I will definitely get the Kindle version of that, and I will give it a read and a review.
Sure.
That sounds absolutely fantastic. So let's recommend that one, even though I only found out about it yesterday, so I haven't read it yet, unfortunately.
Yeah. So Kindle version you can download in seconds.
Well, thank you very much, Steve, for joining us. This has been fantastic.
Thank you, David. It was very enjoyable. It's nice to catch up with you after probably about 25 years or so.
Yeah,
Maybe it's not that much.
exactly.
Let's not take another 20 years. Let's do it
No,
more
no,
often.
we could do a part two because I've got more questions. So, but we'll
Check
call it
one,
quits
two,
for
three.
today.
Yeah. Okay. Thank you very
Awesome.
much.
Thanks, mate.